All right. Hello, everybody. We're going to wait just another probably 30 seconds or so and let some other people jump on. All right, we will go ahead and get started. Hi, everybody. Welcome to the GridPoint webinar, Energy Savings Models, Understanding IPMVP. This is a webinar that was specifically designed for facility managers and energy managers. In this session, we'll guide you through the various energy savings measurement methodologies for your facilities. We'll delve into the importance of tracking and measuring your energy consumption, and we'll shed some light on the reasons behind IPMVP status as the globally acclaimed standard. My name is Marcia Degnan. I'm the Vice President of Marketing Strategy here at GridPoint. I'll be the moderator today. Thank you, Jack. Recording the slide. I will be joined by Jack French, our Senior Manager of Energy Analytics at GridPoint. Jack's passion for sustainability led him to GridPoint in June of 2016. He has been leveraging data to add value to GridPoint customers ever since. Jack took on a former leadership role in 2020, developing our site acceptance and proactive monitoring teams. His experience spans multiple disciplines, including data validation, advanced analytics, measurement and verification, customer engagement, and control optimization. He also holds professional certifications in energy management and measurement and verification through the Association of Energy Engineers. So a couple things before we begin, a few housekeeping items to go over. Please use the Q&A feature located in the menu at the bottom of the screen to submit any questions during the presentation, at any time during the presentation. We have set some time aside at the end of the webinar to address any questions. If you're experiencing any technical issues during the presentation, please send me a message through the chat feature directly to myself, and I'll help you troubleshoot. Please note that there are poll questions throughout the presentation. Jack or I will prompt you when it's time for a poll, and then the answers will automatically display on the screen for you at the end of the poll. Lastly, there is a survey that we kindly ask everybody to complete once the webinar concludes. It's a quick survey, only 6 questions, should only take a minute. We are recording today's presentation. The on-demand version will be available on our website within the next few days. All right, now to get into the agenda. Jack, if you can move, thank you very much. All right, so today what we're going to cover, measurement and verification of energy efficiency projects, the different types of M&V methodologies, whole facility model, and weather normalization and the types of energy savings. So to kick it off, we'll talk measurement and verification of energy efficiency efforts. So Jack, question I have for you is, if I'm a facility manager and looking to track my energy efficiency efforts, what are the steps I need to take to set up M&V on my EE projects?
Yeah, for sure. So I'm going to start out with a failure to plan is planning to fail, right? So in order to get yourself going in the right direction towards a good plan that's going to be representative of what it is that you want to achieve, first step is really determining goals. So it's important to understand what you want to achieve with your energy conservation measure, or ECM. I'm going to say ECM a lot during this webinar, just as an abbreviation acronym. So once you determine what you want to achieve with your ECM, you can determine how you want to measure it. So there's a balance there to be struck between accuracy and cost. And generally, the higher the accuracy of the M&V approach, the greater the cost, because it's going to be more intensive in terms of resources, time, and people. So once you've determined your goals and identify the M&V approach, you can begin meter installation, calibration, and planning for ongoing maintenance. So this is the commissioning process where everything is getting set up. And you might be installing temporary meters for spot checks or ongoing metering for trending of data over time. Ongoing metering approaches, you'll want to have continuous commissioning plan. So that involves, periodically making sure that your meter remains in calibration, and keeping up with maintenance of it so that you make sure that your measurements are accurate throughout the lifespan of your M&V project. So that way you can also choose an existing meter, such as the utility meter, to leverage billing data to quantify the impact of your ECM. That obviously wouldn't require any installation, so it would be a little bit cheaper solution. So once the meter has been installed and commissioned, you can begin data gathering and screening. So this process is going to involve analyzing the data and excluding outliers or adjusting the data if there are events outside the scope of your ECM that might be influencing your data set and skewing your data. So with a valid data set in place, time to determine a computational method and acceptable estimates. So depending on the scope of your project, evaluation of the data might be a simple one-time spot reading, or it could be a thorough ongoing process where you might want to create and maintain a model. And this is sort of where cost and accuracy come into play. So maintaining a meter and a model obviously takes time and potentially funds to allocate, or potentially a contract analyst if you don't have an analyst in-house. And then once computations have been performed, then you prepare for reporting, quality assurance, and third-party verification. Reporting might be required as part of an energy savings performance contract. So this is a really common strategy with ESCOs. And in this case, all the steps leading up to it are vital because you want to make sure that you're meeting your energy savings performance contract, and ongoing reporting demonstrates the performance of the ECM over time and may surface the need for quality assurance. So this is also kind of where continuous commissioning comes in. And then third-party validation of your M&V methodology and results helps to ensure that your ECM performance is demonstrated accurately in your reporting.
Great. So what are some of the main benefits or the key benefits, and why would someone want to do this?
Yeah, absolutely. So a lot of benefits to measurement verification. Kind of the top ones are going to be promoting the success and demonstrating meaningful savings and meeting the goals of your ECM. So you remember step number one in thinking about an ECM and measuring and verifying is setting a goal. So make sure that the savings is meaningful towards your goal. And it also helps to document financial transactions, like we mentioned, energy savings performance contracting by ESCOs. And this is where the ECM can be paid for by the savings it yields. So having a strong M&V plan can help promote that documentation and making sure that the findings are valid and accurate and meaningful. A strong M&V plan enhances the transparency and credibility of its findings. So we talked about third-party validation of the model, so credibility and transparency, documenting your plan, and following a prescriptive methodology and thoroughly documenting each step increases confidence of sponsors and financial partners.
Do you find that there are a lot of challenges to tracking this information? Can you point out a couple of them?
Yes, there are many challenges, but I'm going to talk about the top three. So one is cost. Some options require a significant investment in time, resources, and capital. So remember the balance of cost versus accuracy. Usually the higher the accuracy, the higher the cost. So if you're doing a one-time spot reading, well, you don't have to have a meter and maintain it and calibrate it regularly. Whereas if you want to trend data over time and build a model, all of that needs to be maintained. There needs to be a calibration schedule that you set up. And obviously maintaining a model can take time as you're adding data to it and adjusting it as anything on-site changes. Data availability is another big challenge. So you might not have access to historical data if you're a new tenant taking over a lease, or you simply might not have a large enough sample size to have a meaningful model and accomplish your goals. And then data quality is the last one that's very common. Is you can have instruments that fail, or you could receive estimated billing data if you plan on using the utilities meter, and estimated data can impact the accuracy of your sample, and it can affect the results of your M&V plan. So a couple other challenges, and really this is a typical pitfall. So a lot of times when folks are looking to measure and verify their energy efficiency efforts, they tend to do peer-to-peer comparisons. And even if the building is in the same city, experiences the same weather patterns every year, there are a lot of other differences that buildings can experience that are going to affect the way that they use energy. So things like building differences. A big one that a lot of folks don't think about is in the Northern Hemisphere here, if you have a building with really tall south-facing windows, you're going to experience a lot of solar gain, especially if your windows don't have any film on them. Or one building might have window film, one might not. But if you're doing an HVAC retrofit, it's important to consider other sources of solar heat gain or thermal gain that the site might experience. So that's a big one. HVAC differences, so number of units, age and efficiency, size and tonnage, zone sensor location. All of these can vary pretty wildly site to site, so peers might not really be a great comparison. And then another big one is asset and employee differences. One that isn't necessarily on this list is foot traffic. So if you have, say I have a burger joint on one side of town is a little bit slower, maybe they serve 100 customers a day, and then there's one down at a city center that serves 500-600 customers a day. That's a lot of doors opening and closing. That's a lot of people in the space breathing. So that's going to yield a lot higher energy consumption, and peer-to-peer evaluation in that case is going to be a mistake. It's not going to be very meaningful for your sample.
All right, and we have our first poll question. The question is, what measurement and verification tactics have you used to track your energy initiatives? Meter installation, calibration and maintenance, data gathering and screening, development of a computation method and acceptable estimates, reporting, or just nope, don't track any of your energy efficiency initiatives. I'll give everybody just a minute to go ahead and fill that out. All right. So I will go ahead and share our results. It looks like meter installation, calibration and maintenance, and data gathering and screening are the top ones. All right. So moving on. Measurement and verification, the IPMVP methodology. Jack, I keep hearing this term IPMVP. Can you explain to me what the IPMVP standard is and how it's used in M&V efforts?
Yeah, for sure. IPMVP is kind of a word salad, so hopefully I don't stumble through saying all this. It's a very long acronym, stands for International Performance Measurement and Verification Protocol. And essentially, this protocol is the DOE's best practice for quantifying the results of energy efficiency projects. It's recognized by a lot of big players in the energy efficiency space, such as ASHRAE, Association of Energy Engineers, and the EPA, just to name a few. A lot of utility companies also recognize IPMVP as being the standard, the industry standard. And at its core principles, accuracy, completeness, conservativeness, consistency, relevant, transparent. So we already talked a lot about accuracy in terms of meter calibration, things like that. Those are all important steps in IPMVP. Working with as complete a data set as you can possibly get. Conservative, don't want to overstate any estimates that you might make, and be conservative with any estimates that you're going to make, so that way you're not overstating your potential savings and efficiency gains. Consistency, this is a big one too. Trying to use the same instruments. You can take two readings with two different instruments, and you can get two different readings. They should be the same. So in most cases, we want to have the same meter gathering the same data, or the same sensors gathering the same data throughout the entire M&V lifespan. And relevant, of course. So if you have a baseline from 7 years ago, that might not be how your facility responds and uses energy today. So that wouldn't be relevant. So using current data sets that are reflective of the way your building currently operates is hugely important in IPMVP's core principles. And then transparency, we already talked about documenting your processes for things like energy savings performance contracts. Transparency is a big one. So understanding how you can prescriptively have this approach and document everything that needs to be documented, so that you can justify you're following the protocol and your savings are meaningful and accurate.
So don't worry, I've already, I think, stumbled on the acronym once or twice in this webinar. So you're good. You're good, Jack. Okay. So I know that there are 4 options or 4 methods in the IPMVP framework. Can you explain the difference between them?
Yeah, for sure. So we have options A through D up here on the screen. Option A, savings are quantified by field measurement of only one key performance parameter, and they define, the energy use of the systems affected by the ECM. So what that is basically saying is this is a spot measurement. right? So an example would be a lighting retrofit where you're taking, say traditional incandescents and retrofitting with LEDs. If you know how many hours you operate those lights per year, you know how many fixtures you have, you can take a spot measurement of how many watts are being drawn when the fixtures are on that are going to be on for however many hours. You can take one measurement before you perform the retrofit, take another measurement, the difference between the two multiplied by the number of fixtures, the number of hours of operation per year, that's your annual savings. And that's a totally legit way to measure and verify a project like that. So that's key parameter measurement. Option B is going to be all parameter measurement. So it's going to be similar, but in this case, you're really going to have ongoing metering. And a lot of times you'll have a baseline established prior to your retrofit or your ECM installation. And then going on, you'll measure the data. So in this case, the savings are still quantified by a field measurement, but the actual use of the systems affected by the ECM are also quantified. And the frequency of measurement ranges from short-term to continuous. So depending on what variations are expected throughout the reporting period, you might have a little bit different approach. You might have to have metering in place for a longer period of time. And a good example of this would be a single HVAC retrofit. So you can sub-meter the HVAC for say a year or at least 2 seasons out of the year to establish a baseline, perform your retrofit, and then meter that going forward. Weather normalize that so that you can compare apples to apples and leave the meter in place during the reporting period. So that way you have ongoing trend data and you can see the variation of how energy usage changes with weather patterns. Then the next would be whole facility. So in this case, you're measuring the energy use of the whole facility or even a sub facility over a given reporting period. And measurements are recorded continuously throughout the length of the reporting period. And this is what we use at GridPoint. So option C is the whole facility. We're taking data from the utility. It can be electricity or natural gas. And we take a minimum of 12 months of data prior to us putting in our system. And then going forward, we collect the bills each month. We weather normalize the data and we can say, here's what you used with our system, and here's what you would have used if you didn't have our system. And that's option C, the whole facility method. And really commonly, utility bills are used because you don't have to pay for a meter. You don't have to worry about calibration. The utility does that all, and you're already getting bills. So this is one of the most scalable ways to perform measurement verification for energy efficiency projects. And then finally is calibrated simulation. So this option is probably the least frequently used, definitely the most expensive and the most estimate heavy. So from calibrated simulation, savings are determined through a simulation of energy use of the whole facility or sub-facility. And this simulation sort of aims to demonstrate how the model actually shows projected performance versus actual performance. And an example might be if you have an energy management program which affects a whole facility, but there were no meters in place beforehand. Maybe it's a new construction, or maybe you're taking over a lease from a previous tenant and you can't get historical billing data. That could be an example application for option D.
All right, going right into our second and last poll question. Which IPMVP methodology does your facility use? Retrofit isolation key parameter, retrofit isolation all parameter, whole facility, calibrated, or none? All right, I will go ahead and leave that up on the screen for just a minute. Okay, go ahead and end this. So it looks like a whole facility is the #1 used. Fantastic. All right, so Jack, speaking of the whole facility model, I know you mentioned a little bit about this previously, but and the GridPoint uses this model. Why would someone choose whole facility over the other 3? What are the biggest benefits?
Yeah, for sure. So there are a lot of reasons you might want to consider option C. And I did mention a few of these, so some of this might be a little bit of a review, but if you're installing multiple ECMs, I need to account for all the efficiency gains that are going to be contributed. This is a good methodology to use because heavy submetering of each individual asset, in the case that you're doing an HVAC retrofit, you're going to do some refrigeration control, and you're going to do high efficiency lighting with LEDs. Instead of having a separate meter for each of those individual assets, you can use the whole facility, and you can tell how much your savings contributed from all of your energy efficiency projects, each different asset type. So if you don't have the time and resources to install and maintain ongoing metering and models, this is a really good approach. So another one is if you have multiple sites with differing ECMs and you need a reasonable way to scale your M&V efforts, this is also a good option because you can use the utility bills and you don't have to have multiple meters for multiple sites with different ECMs. So a little bit about how the whole facility method works, and that's what we're sort of showing on the screen here, is the first step is going to be creating a baseline. So this is how we do it at GridPoint. We take 12 months or 24 months of your data, utility data, prior to the installation of the EMS in our case. And the reason that it's 12 or 24 is because you want to have a full set of seasonality. So 12 or 24 months, usually directly leading up to the installation period. So again, remember core principles, the data should be relevant. So 12 months leading up to 12 or 24 leading up to the installation period. And then we model that energy usage data. It could be, kilowatt hours of electricity, it could be CCF natural gas, whatever it is, whatever fuel type it is. We model that with the weather. So that way we can determine how weather is going to influence how the building is using energy, because we're primarily controlling HVAC. So we're primarily controlling your heating and cooling equipment. And understanding how the weather is going to influence that is very important, because the warmer it is, the more energy you're going to spend to cool, and the colder it is, same. So by creating a baseline and understanding the relationship between weather and energy usage, going forward, we can predict or model an adjusted baseline. So that's basically what would be without the ECM in place. And then we compare that modeled or adjusted baseline energy to the actual usage from the ongoing utility bills after the installation of the ECM and the ECM is fully up and running. The difference between the actual usage and the adjusted baseline energy is going to be your savings or your avoided energy consumption. And in this case, it's avoided energy because it is what is versus what would have been without the ECM. So remember the hypothesis statement, if independent variable, then dependent variable. In this case, weather is the independent variable. So what we're looking at is if the weather does something, the energy is going to be responding in some other way, right? So that's how we arrive at adjusted baseline energy by looking at the historical trends. We know that if there's a 80-degree day, we're going to use 1,500 kilowatt hours of electricity for cooling. And that's how weather normalization works, kind of in a nutshell. And we're going to get a little bit more into that very soon.
That brings me right down to my next question, actually, Jack. Weather normalization. Obviously, weather plays a significant role in energy usage. Can you talk to us about how weather normalization and the impact that it has on this verification model?
Yeah, absolutely. So what we tend to use as far as weather data are going to be two metrics. First is called heating degree days, and the second is called cooling degree days. And don't get too hung up on the units because it sounds like it doesn't make any sense. But essentially, heating degree days are how much does the building need to be heated and how much does the building need to be cooled. So these sort of define the energy intensity required to condition the space. And the pivot point is 65 degrees. So 65 degrees is what we would consider a baseload temperature. So at 65 degrees ambient temperature, so outdoor temperature, you shouldn't need any cooling or heating. And your baseload is going to be your lighting, your plug loads, your POS systems, anything else that uses energy that isn't dependent on weather. And HVAC is obviously very dependent on weather. So this is kind of how heating degree days and cooling degree days work. When we look at this daily average temperature plot for a 79-degree day on average, that's going to be 14 cooling degree days because we're cooling from 79 down to, nominally 65. That's not going to be the set point, but that's how far 79 is from 65. So that would be the cooling intensity in a way for that day. And then heating degree days are just the same, but they're on the other side of 65. So think of 65 as kind of the x-axis or the 0 point, the pivot point for degree days. And on a day that's 62 degrees, we'd have 3 heating degree days because that's the difference between 65 and 62. So that would be relatively low heating intensity for that day. And as you plot this over time, so at the bottom, we have a plot that shows an annual trend of heating degree days and cooling degree days. You can see obviously like February was by far the coldest month, 1102 heating degree days. And then July was the warmest month, 347 cooling degree days. So if your building has electric heat, you might expect your energy usage trend to be really high in the wintertime and a little bit lower in the summertime because of the influence of degree days and the intensity required to condition whether that's heating or cooling.
So when it comes to pulling all this data together, when it comes to the actual savings, and thank you for jumping to the next slide, what are the different savings types and how do you track those?
Yeah, for sure. So there are 2 main savings types. Kind of touched on this already, but a little bit of review. So avoided energy consumption is number 1, I guess. And this method relies on the reporting period's operating conditions, and it shows, what is versus what would be with regards to energy consumption. And, to kind of summarize, avoided energy consumption explains how the energy conservation measure performed under the reporting period's conditions. And another savings type would be normalized energy savings. So this method uses a fixed set of conditions, often during the baseline period, to explain how performance compares to normal operating conditions. And to summarize, this approach sort of regulates savings reports so that they remain more uniform regardless of current conditions of the reporting period. And we have a little bit of data here explaining weather normalization. This is sort of back of the envelope. So we have your baseline year, year 1, year 2, year 3, and then your KWH. And if you look at raw savings, so if we look at baseline versus year 1, during the baseline year, we used 40,480 kilowatt hours. In year 1, we used 45,840 kilowatt hours. Well, that's an increase, right? So that's negative 13% if we look at raw savings. But if we look at the degree days, only 520 heating degree days in the baseline year, 681 in year 1. So the heating intensity was much higher in year 1 as compared to the baseline year. So if you normalize that, essentially take your KWH, divide by degree days. So KWH per degree day, this column third from the right, you end up with 14% savings because that's a difference of 78 in the baseline year to 67 in year 1. And the option C weather normalized model is essentially a multiple linear regression. And this allows us to figure out how weather influences energy consumption. And we use a statistical operator called coefficient of determination, or R squared. And this determines how the variation in the data is explained by the model, or rather, how well weather can predict changes in energy consumption. And there are other statistical operators you can use. A lot of people use CVR MSE, and that's another good one too. But basically, you want to determine that your data set is meaningful and statistically significant. So there are more than one way to do that. R squared is a really good one. Bring you back to high school linear regression modeling.
Thank you very much, Jack, for that overview. And I know we do have a quick case study. Do you want to touch base on this to show how we have achieved the savings using that whole building or whole facility model?
Oh, sure. So this is an example of how we would present savings figures to an enterprise. So you can see in this case of the sample, we have 44 sites with valid and significant electricity data, 43 sites with natural gas data. And savings began somewhere around 2019 and end June 2022. So this is the reporting period. November 2019 to June 2022 is our reporting period. So for this customer, we established baselines, 2 models per site, one for each fuel type, electricity and natural gas. they were obviously weather normalized, so we could figure out what is versus what would have been. So modeled usage tells us what would have been without the energy management system, and actual usage tells us what truly was with the energy management system. So it ended up being a combined savings of about 10 million avoided kilowatt hours. And that's pretty significant, and a percent reduction about 23.3%, and a total cumulative savings of about $950,000. So pretty compelling stuff. And there are some definitions of, at the bottom, modeled usage, what would have been actual usage, real build usage. And this is a great case study for how option C methodology works in the real world.
That's a significant amount of savings. Great. Well, that concludes our presentation and our webinar. Jack, appreciate the insight into IPMVP. We do have a couple of questions, so we'll take a couple of questions, and then if you have any more, please go ahead and submit them into the Q&A section. The first question, why do I need to weather normalize?
Okay, it's $5 per question. That's the going rate. Okay, weather normalization is especially important for projects where you're dealing with heating and cooling equipment, especially. If you're doing an LED retrofit, it doesn't matter. It doesn't matter how hot or cold it is. You're going to have lights on when you need them on. So whenever you're performing a project that is going to be influenced by ambient temperature, outdoor temperature, it's extremely important to weather normalize, because it really helps you compare apples to apples versus apples to oranges. If you look at raw consumption, if we go back a couple slides, that's exactly what this demonstrates. This demonstrates the importance of weather normalization. So it's a great question. Because if we look at raw usage, 40 versus 45,000 kilowatt hours, well, we'd say, oh, we consume more energy. What's going on? But when you throw weather into the mix, since there was a higher heating intensity needed in year one compared to the baseline, you actually do have 14% savings. So, by skipping weather normalization for projects that are going to be influenced by weather, you are kind of shortchanging yourself in terms of accurately measuring what your performance of your ECM is.
Great, that's a great answer. So our next question is, will I see savings on my accounting, P&L, or balance sheets?
This is one we get all the time. And in short, the way that accounting and energy management savings are looked at are just fundamentally different. So if we look at P&L or balance sheets, what we're going to see is what we spent this year versus what we spent last year. And your spend is going to include your utility costs, right? And utility costs not only can change, but especially weather could change. So this goes right back into, why do I need to weather normalize? And this example perfectly illustrates why you might not see the savings that are being reported on your raw invoices for P&L or for balance sheets. So in the case where let's take an example where we have a site in North Carolina and had a pretty mild summer. Average temperature was 80 degrees, which for the Carolinas is pretty mild. And then the following summer, the average temperature was 92 degrees. Well, that's 12 degrees higher on average for the whole summer. That means you're going to consume a lot more energy for cooling. Remember, cooling degree days, anything above 65 would be 66, 67. That's 1, that's 2 cooling degree days. So in a summer when you have 92 degree average temperature versus 80 degrees, you're going to consume a significant amount more energy. And if you put an ECM in, you did an HVAC retrofit, you did a smart thermostat, whatever it is, if you look at the raw cost on balance sheets, it's going to lead you to believe that you consumed more energy, but really you probably saved energy because your cooling intensity was much higher, but your energy consumption and cost would have been significantly higher had you not put that ECM in place. So that's really the purpose of sort of weather normalization, is figuring out how weather plays a factor in your energy consumption, and then therefore the energy cost. So that's another pitfall. Looking at accounting, P&L, or balance sheets is another pitfall.
Great. So our last question we have is, where should I start when considering ECMs and M&V approaches?
Yeah, that's also a great question. A good place to start is where we started at the beginning of this presentation. Failing to plan is planning to fail. So come up with a plan, come up with meaningful goals, obviously. And when you're considering ECMs, start low cost, no cost. If you can put some weather stripping in, if you can make sure that you seal any air gaps, if you can even do behavioral changes for however you're operating your sites, make sure exhaust fans are turned off at night, make sure lights are turned off at night, make sure that anything that uses energy is set back or turned off when it doesn't need to be operating. So those are great places to start. And then from there, you can get a little bit more deep into the weeds with what you want to do as far as an ECM. And then that will help steer your M&V approach. If you think, okay, well, maybe this year I'll just do an LED retrofit. Okay, great. What's your goal for your LED retrofit? And then, what do you want to accomplish with your M&V? Can you do a spot check? Is that going to be significant enough? Do you have reasonable estimates of your operating hours? Things like that. And then, considering deeper ECMs like equipment retrofits for HVACs or doing any refrigeration control, that's going to require a lot deeper metering and a lot deeper investment. And documenting those financial transactions and making sure that you can prove with transparency that your ECM is performing the way that you had expected it to, and that you're meeting your goal.
Fantastic. All right, well, that was our last question. Thank you everybody so much for attending our webinar. As I said before, we will have this available on demand on our website in the next couple of days. You'll also get an email with a link out to it as well. Jack, thank you so much for sharing that insight. Incredibly helpful. So appreciate everything, and hope to see you guys on the next webinar.
Thanks, everyone.
Bye.